Hello, welcome to my channel. So we are going to see today parallel streams in Java. So first of all, we are going to check number of cores in my system. So I'm going to call runtime.get runtime and available processors. And let me show you how many number of cores I do have, number of processors on my machine because it affects parallelism. Okay, so let me run this. So I'm going to run this and we'll see what is the output. So as per my knowledge, I have 8 cores. Okay, you can also see these cores if you do control alt delete and control alt delete, and if you open task manager, and you can see here number of CPUs. You can see there are 8 CPUs. Okay, all right. So I have 8 number of cores in my machine. You can check how many number of processors you have on your system. Now let's start with the let's create one array list. Let's create array list of integer. Okay, array list of integer, and yeah, let's populate this array list. So uh, let me create one array, and let's add some values. Uh, let's take you know 20, 1 to 25 number, and uh, what I want to do is I want to add uh, some. Yeah, let's add I. Okay, so this way I have right now. Let's do for each loop, and let me print this numbers. Okay, so this is the lambda shortcut for uh, printing numbers. So we can see here number of processor 8, and we have printed 1 to 25 numbers. Now let's start. Let's do some operation on this number. Okay. Since this is a serial stream, so let's see if I do parallel stream, what happens. I will add parallel stream, and now let's see how, in what order these numbers are printed. And you can see the numbers are printed in random order. So it's because it's a parallel stream, and whichever thread gets first CPU first, it is executed. So in this case, 16 number got executed first. Okay, and it got printed. So yeah, so what we are going to do now is we are going to do a benchmark, simple benchmarking. So what we are going to do is, first of all, let's take the uh, initial timestamp. Okay, and then once we perform the operation, let's take the final timestamp. Okay, and I have total time is equal to end time minus start time. Okay, and let's print this number, total time. Yeah, so I'm printing this. So just now I'm printing this number. So let's see, the print operation doesn't take much time, and actually we should have added here some text. The total time taken is milliseconds, right? So let's add milliseconds. Okay, now, so total time taken 11 milliseconds. uh, let's run one more time and see if, so there is a minor variation, but more or less it's around 11-12 milliseconds. So it's for parallel stream. Now let me remove this parallel stream and see how much time it's taking. So it just took 2 milliseconds for Siri to execute this thread serially. So you can see it's a 2 millisecond for serial, and it was taking around 12 milliseconds for parallel. So what we have taught is like parallel stream should always outperform, but this is not happening here. It's because it's because uh, it's because the way parallel stream works is, or in general multi-threading works is, it has a lot of overhead, uh, to maintain this number of threads created, manage them, and destroy. Okay, so I'm just modifying this program a little bit. I'm going to add minor sleep over here. Okay, so I have added 10 milliseconds. So what I'm going to do is, rather I'll take 5 milliseconds. Okay, 5 milliseconds sleep I have added, and let's see what happens. So it was taking 2 milliseconds. Now it takes 139 milliseconds. Okay. So the time taken is now shoot up from 2 milliseconds to 139 milliseconds. All right. Now uh, this is about serial thread. And now let's check with now interesting thing is going to happen. What I'm going to do is I'm going to iterate it for each loop in parallel stream, and let's see what happens. Oh, it's just taking 30 milliseconds to perform all the operation. 31, right? So when I added the sleep, then my parallel stream actually became more efficient. So what does it mean? So if you have, so it means, so what we can conclude here is, if you have simple operation, arithmetic, simple operations which are not going to get blocked anywhere, those better be done on normal stream. So and if you have some input output operations, network IO operations, then that those should be done in parallel stream. In either case, one should always do benchmarking in the program. For your particular use case, you should do benchmarking. You should try both streams, parallel streams and serial streams, and check the performance. Just like the way we have done, right? We have taken start time, end time, and we are just using that time. So yeah, that's it from